Good morning, everyone. I hope I'm audible. So, before I start, I'd quickly like to thank all the organizers and a special thanks to Sonia for inviting me. So, now I'm going to talk about agentic AI, how it's relevant to us, and how we are going to use it in the real world. Now, I want to start with a number, not a quote. JP Morgan built Coin, Contract Intelligence. It reviews approximately 12,000 commercial agreements a year. That is 3,60,000 lawyers annually. And that's being done in seconds. I want you to hold this fact not as an not as a statistic about efficiency, but about what becomes possible when we turn intelligence into infrastructure. My name is Aditya, and I'm building agentic systems since the last 4 to 5 years, from NLP pipelines to complex agentic flows. And as I said today, I'm going to give you a map what AI can do, how much it costs, and what it cannot do, and what you should be doing right now in your specific role. Now, let me quickly start off with a topic that most of us are familiar with. How did AI come to be as it is now? So, for 50 years or so, we were in the era of instructions. We had to give in the logic, the rules. Only then we got a result. It was fast, reliable, but it was completely rigid. Later, we moved to machine learning and deep learning, where we shifted from rules to patterns. Instead of telling the system how to recognize and face or translate a sentence, we just gave it millions of examples and let it learn. Then we witnessed an explosion, generative AI. Instead of just understanding patterns, it started creating them. The summarizing a 400-page report, creating code blocks, writing an email, and more. Now we are witnessing a fundamental shift in technology from systems that respond to prompts to systems that act. This is agentic AI. These systems will take action, act, and can come back from failure autonomously. Now, you might be wondering what makes these systems go from talking to doing. There are four main pillars behind this. The first one is perception, where the agent understands the entire environment. So, the code block the code editor that you opened, maybe an CRM or SQL database that's connected, or maybe some live web files that you have shared with it. The input is no longer just the text box, it's the entire environment that it has access to. Secondly, we have planning, where when you given a goal to the agent, it breaks it down and decomposes it into subtasks. So first I need to do task A. Then based on the output of task A, I want to task B and task C. It creates its own execution chain. And this is the game changer. The change from reactive to intentional. Thirdly, we have the memory layer. And this is one part that most production agents go wrong in. We usually have the short term memory, which exists for that conversation. But long term memory, this requires explicit persistence logic, state memory, and more. When you don't code this long term memory, every time you interact with the agent, it starts from zero. It cannot learn from its past interactions. And lastly, we have the actions layer. This is like giving your agent its own hands. It can run an SQL query, interact with API calls, and work in your actual environment instead of just a chat box. Now, for those who are thinking this isn't science fiction, it's ground reality. In the last few years, we are seeing a massive explosion in the frameworks that are making this possible. For example, we have LangChain and LangGraph, which are extremely reliable when you need state management and you have chains and linear flows. Then we have Autogen, which is one of the early pioneers in multi-agent technology, where one agent interacts with multiple agents. And lastly, we also have Crew AI, which is mostly based on role-based orchestration. So, for example, a research agent talks with a writer agent who talks with a compliance agent or audit, you would say. Now, most agent frameworks are model agnostic. That is, they can work with mainly any modular service provider. This might seem like a benefit, but in reality, it's one of the major architectural decisions you're gonna ever make. It directly impacts your cost and scale, your data privacy posture, and your data sovereignty. So let me simplify this using this table. We have two dimensions. The first is capability, where you have large language models and small language models. And on the other hand, you have deployment, cloud deployment and self-deployment. Let's start with capability. So LLMs are like a reasoning layer at an scale. So you should use them for tasks that require not just processing, thinking. So tasks such as code generation, long document understanding, and generally any ambiguous and unstructured tasks. Some models, GPT 5.4, 4.6 Opus, and Gemini 3.1 Pro, these are some of the latest models that we have. And these are mainly good for instruction following, reasoning, and all these factors make it good for agentic systems. On the other hand, we have SLMs. And the main motto of SLMs is that we have these tasks that don't require deep reasoning but have to be high volume. So things like summarization, classification, extraction of keywords, etc. So we use these models. Now, in real-time architecture, we are not going to use a single one of these. We are going to use model routing systems. So, using LLMs for the complex paths where you need reasoning and thinking, and SLMs as your bulk layer at scale. Then, coming to the deployment, cloud hosted models offer you two main advantages. The first is speed and the ease of management. Everything's managed and you pay per token. Whereas the thing that occurs here is that you trade off your data privacy and your long-term cost. Whereas self-hosted models, they help you maintain data sovereignty. You have full access to your data and full control of it. And also you have long-term cost predictability because apart from the one-time hardware and the electricity, the cost practically zero. Now, you might be asking, why does this matter to me? As an architecture, as an organization or an individual, we have moved from an era of humans versus machines into the era of the multiplier. Previously, if you had to do the work of say five people, you had to hire five separate members. But today, a single person with agentic systems can do the work of five people with compatible proficiency. Now, over the days, in multiple companies, there are AI decisions being taken at an accelerating pace. So, without further ado, let's look at some of the most common things that are being implemented right now. So, the first one is knowledge assistance using RAG. Companies such as KPMG and Deloitte, right? So, these are two of the big four companies, as you're aware. So, they need to audit data, and traditionally they utilize 5% sample data. But now, with the LLMs, they are able to synthesize 100% of the client's transactional data. And the work of the auditor, it's changing from finding the anomaly to explaining it. Then we have AI co-pilots. As per an internal report by Goldman Sachs, nearly 30 to 50% reduction in time was seen after implementing these co-pilots across all the engineering teams. Their employees have told that they are taking less time to write boilerplate code. And the metric here that is saved is not just time, it's a cognitive shift from writing syntax from scratch to reviewing it. This is a higher value function.